Hello, everyone. I will be talking today about SIGTRAN, but more specifically about M2UA. SIGTRAN is a combination of multiple types of signaling interfaces. You can have M2PA, M2UA, M3UA, and other types of services here. However, here I'm going to concentrate on the M2UA variant of the SIGTRAN protocol. I'm going to go over today SIGTRAN M2UA overview, so explaining all the different modes of M2UA. I will then talk about the specific support on the TelcoBridges products, what it can or cannot do. Then we will show you some configuration on a lab setup I have here in my environment, in my lab environment. I will show you the status, what you can get as a status for M2UA, and show you some troubleshooting tools and how to use those. So the M2UA SIGTRAN protocol is used to either terminate the SS7 signaling over IP, and this we call it the ASP mode. Right? So we take the traditional SS7 upper layers and we're terminating, but using IP instead of TDM. We can use it to relay SS7 signaling over IP. So then this is called the SG mode, signaling gateway mode. So then we get those TDM links inside the device, and then we send that out to a IP network. The upper layer, in upper SS7 layers remain there. And the other third mode we have is relay MTP2 links over IP. So then you have MTP2 links at both ends, and we use the IP network to relay end-to-end the traffic. The SIGTRAN M2UA protocol replaces the MTP2 links. So instead of having MTP2 links, you have your M2UA links. It has the same functionalities. The MTP2 links are usually 64 kilobit per second, and it carried over trunks, T1, E1s, and time slots. So 64 kilobit per second time slot. But when you use M2UA, then you use an IP port instead. So it's a local IP, local port, destination IP, destination port. Since it's over IP, then you have also higher bandwidth. And usually only one M2UA link is necessary to carry all the MTP2 links. So all the MTP2 links are regrouped into one M2UA SCTP association. Okay, so M2UA runs over SCTP on an IP network. Okay? SCTP has some advantages over TCP, is that it has multiple streams in the same socket connection end-to-end. Okay, you can have priorities in there, so it's more efficient than traditional STP. First mode of M2UA is the ASP mode, so that's application server process. So, and that is used to terminate the eyes up and SCCP signal. So what you do, well, what was done traditionally is that you had T1 E1s and time slots coming in. So these time slots, they carry MTP2 traffic. So you get those T1 E1 time slots into the system. And then the upper layers here, MTP3 to route the SS7 traffic, and the upper layers here are being handled on the device. Okay? So the eyes-up network here on the left side is used for controlling media calls, okay, or voice calls or fax calls. And this media, even if this, when this is TDM, then the media is also TDM. The other layer that can terminate here is SCCP, and then this is more for data type traffic over SS7 network. Over SCCP, we have TCAP that runs here, and above TCAP, we have other services, and one of them is a good example is SMS packets being sent over the TDM network on an SS7 infrastructure. So we can do the same with M2UA. So instead of receiving TDM traffic over T1 E1s and time slots, we can receive them with IP and ports. So then you get the M2UA information, but the upper layers are still MTP3, still eyes up SCCP. So there's no change on these layers. When I show you the traces, we will take from the system later, you will see that it's exactly the same. However, the media remains TDM, right? So it's still TDM. It's only the signaling that is now on the IP network. The media is still on TDM network. If I show you another representation of this, you have the devices here that can get the M2UA links from the SS7 network. SS7 network is now an IP-based network at this level, and then you have different components out of the SS7 network. Service switching points, signaling transfer points, right, where you can send traffic, or you have also SCPs, which I didn't show here. But you have all these elements in the network, and instead of using TDM here, we use our M2UA links to connect to those systems. In a SS7 network like this, each element here have their own point code. So we also need to have our own point code on the system. These are configured at the MTP3 level. So what we need to have here on our systems is to have the M2UA in ASP mode, so we can terminate the traffic. We have our IP and ports here, and all the upper levels of the system here, that then we go all the way up to call control, where you can control your voice circuits in the TDM mode. Right, so this is the SS7 termination mode. The other mode you can have is the signaling gateway mode. And in this case, it's used to relay SS7 traffic. So all the upper level, MTP3, ISUP, SCCP, as we show here, are being transferred end-to-end from the TDM network here. So T1E1 time slots coming into MTP2. And these are relayed to M2UA. So it's just a patch that we do here to take MTP2 packets, reformat them in M2UA, and then send that over IP to the destination, M2UA destination. Okay, so this side is TDM, this side is IP. The reference between the MTP2 links here and the M2UA links here is what we call an interface identifier. So on this network here, you will have a reference, let's say, for example, 100 here. So this interface identifier will be presenting this particular MTP2 links. And if you have another MTP2 link, then maybe it's going to be 101, right? So the next link that you have here will be 1. But this will be on the same SCTP association, so one association, but you will have two interface identifier in the same M2UA. Of course, if they go to the same destination, because you could also have multiple destination for multiple links. And in this M2UA signaling gateway mode, there's no media. There's no media because the information is just passed to another element in the network. We don't need to manage the media in this case. So when we use the signaling gateway mode, we have an SS7 network here on the left side, which is TDM. And we have another SS7 network here, but is on over IP. So here I called it a SIGTRAN network. So you have your SS7 MTP2 links on the TDM coming from here, and SIGTRAN M2UA on SCTP IP on this side. So this just relays the traffic, and you can see here the TDM networks can be any kind here, T1s, DS3s, OC3s. You get those MTP2 links, and you repackage them in M2UA going to the SIGTRAN network. Since we are staying at the lower level of the system, we do not require a point code here. Okay, so that's an advantage in networks because the point codes that are here and here don't need to know about our system here. They talk only directly to each other end to end, and we only convert the traffic from TDM to IP. The third mode is called the ASP relay mode. And this is used to relay MTP2 links over an IP network. So what you have on the left side is SS7 MTP2 links. And on the right side is other SS7 MTP2 links. But in the middle here, what we do is we send that over IP. One of these elements is a signaling gateway. So that's exactly like the previous slide you saw. But the other side needs to be configured in ASP relay mode. So this is a special mode where you act as an ASP for the signaling gateway. So the signaling gateway thinks you're an ASP here, but then you will, instead of keeping the traffic locally, you will send it out to the TDM network. Okay? So there's different reasons why we want to do this, but the main one is that on this side and on this side, you don't want to change your systems. This could be maybe old links to old systems, which you can't change the configuration or something like that. I have also seen that here, you know, it goes through a satellite network, maybe to remote regions. And then the satellite links, these satellite TDM links are being decommissioned. So you can't use TDM links on satellite anymore. You can only use IP. So then this is a good solution to send the traffic end to end without needing to modify both ends. Both ends will see exactly the same as if it was a TDM link. Okay? So I will not spend a lot of time on this particular configuration because it's a special case of M2UA. So I will concentrate more on the SG and the ASP mode. So the SIGTRAN support on the TelcoBridges platform is, well, there's two types of platform that can support this, TMGs and TSGs, so media gateways and signaling gateways. So when you do the signaling gateway mode, then all of them are supported. So you can take any platform to support SG mode. But if you use the ASP mode, then you need to terminate the traffic. So only the media gateways will be available to terminate the traffic. Okay? You need to have M2UA link license to allow support for these M2UA. And for signaling gateway mode, then you need also to have the MTP2 link license. And you see here the maximum number of links that are supported on the different platforms. So configuration concepts, so if we can dig just a bit deeper into how we configure those systems, you have here on the left side your MTP2 links, and you have your devices, which could be in a signaling gateway mode, a TMG or a TSG device. To allow configuration of M2UA, you need to specify from which interface you want to send the traffic and your local IP and port. You need to have the remote IP and port here of the system. So it could be it could be a M2UA STP, or it could be a media gateway controller, right? So we can send those M2UA traffic to those devices here. And that's all we need for configuration. The only thing else is the interface ID. Right? So this particular MTP2 link will need to be identified at this level here so that this remote system understands that this interface ID represents this MTP2 link, because the MTP3 will need to be here, right? So the MTP3 layer will need to be here, and it needs to understand that this link is attached to this MTP3 network. So in this case, there's one peer. You see it here, one IP, and a single SCTP association. Another example is that if you have two MTP2 links here, each one of them, well, the rest of the information is the same, right? Network interface, IP port, remote IP port, and then you need to identify each of those TDM links. So here, what you need to do is create a cluster. That cluster will have an interface ID for each of those MTP2 links. And here it's clear that the first MTP2 link will have this ID, and the second one will have this ID. It's still only one peer, one IP, and a single SCTP association. But inside that cluster, you have two interface IDs. Each are processed separately inside that M2UA link. And then there's all kinds of other configurations you can do. For example, here you could have, instead of one IP, you could have two IPs. Okay, so that's the same single SCTP association, but with two possible destinations. Okay? You could have also, if I go down here, you could have two peers, two different peers for the same cluster, and then each of the peers have their own IP and port. That creates two SCTP associations, and you can send traffic on one or the other depending on the mode. If you have active standby mode, it will send only on one, and then if that one is down, it will send on the other link. If you use load sharing, then it's going to balance the traffic between those two SCTP associations. The other mode you can have is one SCTP association and one cluster for one link, and then another association with another cluster to another peer with the other link. Right? So these are completely two independent links. So then viewed from these elements here, they see only one MTP2 link on this side. So we can do multiple connections like this. In this case, there are two clusters and there's one destination per cluster here. Right? And the last mode I'm showing here is that locally, we can also have different local interfaces to send to remote systems. Right? So before starting configuring M2UA, you need to understand what is the mode we need to configure, and then we need to apply this configuration to the system. If you don't think about this before, then it may get complicated to understand how this needs to be configured. So this was the signaling gateway configuration. On the ASP configuration mode, it's similar. So you have ASP mode instead of SG mode for the M2UA. And then you terminate the traffic. But then this interface ID is not related to any MTP2 links, right? It's just local between those two systems here. And they need to understand what is the, let's say, the interface between the interface between for that particular M2UA. So, and for ASP, you can have all kinds of other configuration like you saw for signaling gateway. So you could have multiple local interface, multiple peer clusters change. So you can also do all of these configuration for ASP. So if I get into the configuration of such a system, you have your MTP2 links, which you will need to configure only if you're using M2UA signaling gateway mode. You need to specify the rate here. So you have here 64 kilobit or 56 kilobit per second, or we have a special mode of high-speed link where then it's the full T1 or E1 that is used for carrying the traffic. And then you need to choose which T1 or E1 you will use for this and which time slot. So you need to specify the time slot that you're gonna use for this. That's all for the MTP2 link configuration. You have nothing else to do. On the M2UA configuration, as we explained before, you need to have information about your local interface, local IP, which VLAN you want to use, if you want to use bonding on those links on this side here. For M2UA, you need to have those remote IPs and port, and also which protocol you need to use. So in my demonstration here, I use ITU, but it could be NC or other values. So if I get to the local IP configuration here, you have on the IP interface, this is where you will configure your own IP interface. You have here virtual ports, which will say which physical virtual port you want to use to send the traffic. If you want to use a VLAN on those physical ports, and if you want to bond those ports together. And then you have your IP interfaces, which are mostly the IP address that you will create on the system. And you will need to specify at least one interface that supports SIGTRAN type of traffic. So let me show you this. In virtual ports here, you can create your VLAN or, of course, untagged traffic here. And then you can configure your bonding. Here we see the result is bonding of the two VoIP ports together to have bonding. And the configuration is done like this. So you select, you give it a name here, you select untagged, or if you remove this, you will see you need to add a VLAN information. And then physical parts, you choose only VoIP 0, only VoIP 1, or then in this case, we chose both, and that creates a bonding between those two elements. And then you need to create the IP interface. So you click here on IP interfaces, and you see here you have the name that you give. For example, VoIP bonded. You choose the virtual port we created just before, and you give your own IP address information. And you need to make sure that you have at least a SIGTRAN service on that particular IP interface. Once you have your IP interface set up, you need to go in SCTP and just enable this SCTP configuration. You will use raw IP, and you can give it a name here. The M2UA configuration, so you just select the M2UA menu, and then you need to enable this, give it a name, so this can be just M2UA. And then the node type here, we have 3 modes we support, which are the ones I explained before: signaling gateway, application server process, or ASP with M2UA MTP2 relay. Okay, there's advanced parameters here. We rarely have to modify those elements. Then you need to create your local interface, service access point. Okay, so local interface to use. You will use the local IP interface. So this is the one we have created just before in our IP interface configuration. You need to also specify the local port for M2UA. It is the default port is 2904. If you can configure any type of port, but if you don't know what to configure, then 2904 is the correct one to use. Right? Then you need to configure your cluster. So you need to have at least one cluster, but that cluster could be only one link, or it could be multiple links. So the cluster is used to regroup M2UA links and destin it towards one peer. Okay. So here you have multiple MTP2 links associated with M2UA and interface ID. Here I show 2 links. So the first M2UA link here with an interface ID attached to an MTP2 link. So here it's a signaling gateway mode, right? So that's why we're bound to an MTP2 link. And the second link here is 55, and it's linked to another MTP2 link. Here, there's also a peer that will configure right after. So if I go inside the M2UA link configuration, you see this, you can give it a name. This name will show in the status. So if it can help you to give a name that is relevant, that is good. Here you will choose your MTP2 link that you want to attach with the interface ID. And here you need to specify the interface ID type and the ID. So here there's two choices, integer or string. You need to make sure you choose the correct one according to the remote site. Okay. And then the interface ID value. So you will do this twice, one for the 54, one for the 55, if you have 2 MTP2. In the ASP mode, the difference here in the cluster is that it will not be attached to an MTP2 link. Okay, so when you select the M2UA link configuration, you will say, well, my MTP2 link is none. Okay, there's no MTP2 links because I'm terminating locally here. You will still need to have an interface ID to identify that particular M2UA link. And you will need to have a MTP3 configuration where you will attach this M2UA link to continue the configuration of the system. Then if you look at the bottom, you have your M2UA peers. So this will be the port of the destination. Then you will need to give at least one IP for that destination, but it's possible that you need to have more than one IP. When you have more than one IP like this, it creates only one SCTP association, and it can be switched from this IP to another IP if one of them becomes down. Okay. Yeah, here you have also number of STP streams. It is like the default value, but it's negotiated when the M2UA link comes up, how many streams will be presented. Okay. So when you have more than one IP, it's a single SCTP association with multi-host. It's also possible that you have two M2UA peer, two independent M2UA peer. All right, so one here, which could have a different port, a different destination IP, another port, another different. This creates really two SCTP associations, and both of them will be able to communicate. In that case, when you configure this, I will just go back here. It's important to choose the correct traffic mode here, which should be active standby, or it could be load sharing. Okay, so you need to choose this. Well, actually, the traffic mode and the load share mode. Need to use both. In a single SCTP association, you still have to configure the traffic mode, but it's not really used in the system. Okay. If we are configuring SG mode, well, our configuration is complete. So you can just go in configurations, in configurations, but system here, and press on activate, and this will activate your M2UA configuration. However, in ASP mode, you still need to configure upper layers, MTP3 and ISA, because you are terminating the M2UA traffic. This is not the objective of this presentation. I will do other presentations to show this part. But once you've configured those two layers, then you can activate the configuration as well. Once everything is configured, you will need to look in the status. So you can go all the way up at the status level here, and then you can see the status of your system. The physical parts, IP interfaces will be here. M2UA will be here. MTP3, if you have those layers, will be here, right? So you will see the status of all your layers from the status. Or what I showed here is the status here, but you can also go in different modules like this and click on the status tab on the upper right here. And then you will see the status of each of your ports. So the IP address, if it's available, what is the link that was negotiated, link speed that was negotiated, the MAC address that is given to that particular port, and all kinds of information here. Okay, so you can see, and also if you click on bonding, you can see the bonding status here. Okay, see which port is currently active. Then you can go on M2UA here and look at the status. If you click on the status and on the particular service access point you have, you will get here. So you have options to look at the links or look at the peers. When you look at the links, you see the identifier, interface identifier that is used, and also the if it's up, and if you see other errors, for example, congestion or processor outage, and then how many packets have been transmitted over that M2UA link. When you click deeper on that M2UA link, you can see the same information here, but you can also change the level to get a bit more information about this M2UA link. So each M2UA link will have different statistics. You can do the same for the peer. So if you click on the peer segment, you can see if it's configured, if it's active, how many packets were being sent there, and if you saw errors, you can see all of this here. Then you can, for testing, particularly for testing, you can change the target peer state. You can do this only if you're in ASP mode, and then you can change here from shutdown, or the default mode is ASP active. So you can say, I want to shut down this link. You can do apply states here. When you do apply states, it takes effect immediately. So the links will, M2UA links, well, here it's a peer. So if the peer has more than one M2UA link, all of them will go down at the same time. And the SCTP association will go down as well. And then you can change it back to ASP active and apply states. There's other intermediate modes here which are not as useful. And it's used for testing, so you can see if it comes back normal on different setups. Okay. Now, for my lab setup, which I will show you now, I needed to configure upper layers, right? So MTP3, because I want to terminate traffic so you can see it flowing through the signaling gateway and the ASP. I need to configure point codes, link set, routes, and then we have E1s and an E1 loopback. And at the ISAP level, I have circuit groups, which links the physical time slots for transferring voice and data. So let me show you the lab setup that I have here. On the left side, okay, so these are two separate systems here on the right and the left. This system here is a TNG in 1+1 mode. So you have, you will see when I show you the status, you always see 2 units, but it's one configuration you do for a 1+1 system. And then I have here my M2UA in ASP mode. These are my IPs I'm using. And I have these upper layers that I'm using for, transferring data end to end, just to show what happens here. Okay. Then on the right side here, I have the M2UA signaling gateway mode. So this is the IP for this one. And you can see I'm receiving M2UA traffic, connecting that to MTP2 here. And then, of course, it's not terminated here. So to be able to terminate it, I did a loopback, and I terminated here, and it's on the same unit. Here, it could have been on another system, but here I terminated on the same unit. So this is trunk 0, trunk 1 configured in loopback. It's the same time slot because I need to get this information. And then I'm terminating the traffic at the upper layer. You see here, my point code will be 702 on this side and 701 on this side. I'm using a local IP network to carry my traffic, but on a real installation, normally we would use a VPN to connect those devices or other VPNs or other services here to be on the private networks. Okay, so I will go right now on my configuration of my system. If you look here, I have my M2UA ASP. So if I look at my status here, you see the things that are being used currently. So some of them are dark. That means they are not configured. Okay, there's nothing configured here. The ones that are green are the ones that are configured and are up and running. Okay, so you can see here M2UA links. And I also have MTP3 here because I need to terminate the traffic. And I have my SS7 ISAP. So I will show you here the IP interface configuration of the system. Here you see I have multiple configurations, but the one I'm using for SIGTRAN is called VoIP bonded here. So VoIP on tag, this is my IP, my local IP. And I'm using a SIGTRAN mode. Oops, if I just go back here, I can see that it's being used for M2UA. Okay, so this particular interface is being used for other stuff, but also for M2UA. Okay, so if I select this interface, you see that I've selected SIGTRAN. I also have RTP and SIP, but you need to have at least SIGTRAN here. And this is the interface I'm using, VoIP on tag. I could have used other VLANs and other ports for carrying this traffic. And then you have your IP address and a gateway you need to configure here. Each interface has its own IP and gateway configuration, right? So each one of them can have their own routing scheme. If I just go step back, because here we see we're using the VoIP untag. So if I just go back one, virtual parts here, VoIP untag is this one here on the bottom. So if I click on that one, I can see that I am using an untagged, but I could have selected that and say I'm running on VLAN 100. Okay. Just go back here. And then I've chose the two parts here. So you can choose only VoIP 0, VoIP 1, or both to have your bonding. Okay. The bonding is created automatically, and you see it here as well, VoIP 0, VoIP 1. If you go back one again, you get to physical parts, and you can see each of the physical parts. Here you see that it's a 1+1 system. So you have a VoIP 1 on primary and a VoIP 1 on secondary. They have the same name. They need to be connected to the same network, even if they're two independent systems. Okay. If I go to the this is the ASP mode. So I have no MTP2 here. I have just the M2UA. So you see here, I've configured the ASP mode. I created a service access point. In this service access point, I have my local port. I chose the interface I selected just before. And then I have my cluster here. If I go in the cluster, I have one M2UA link. I give it an interface ID. The interface ID is a virtual value. So it just needs to be the same as what you have on the remote side. And you see here, it's not bound to an MTP2 link. It's bound to an MTP3 layer. Right? So it's an ASP, so I'm terminating MTP3 here. Then you have the M2UA peer. So this is the destination where I will send the M2UA traffic. So if I look here, M2UA peer, I have the destination IP. I could have put more IPs here if the remote system supports this. And then that's it for ASP mode. The other layers are MTP3 here, and I can show you quickly what it looks like. You have your link set here, and you say I'm using at the MTP3 level that M2UA link to carry the MTP3 information. Okay? So I don't want to go into this upper layer configuration. I just wanted to show that the M2UA link is being used for this. Okay? So this is all for the ASP mode. Let me show you the signaling gateway mode, which is here. So that's my other system facing this one. If I look at the status here, I have more things running on this system. Some interfaces are down. You see here, I'm not using VoIP 0, I'm using only VoIP 1. I have some TDM lines that are up, some that are down. What we need to look at more here is the MTP2 and M2UA configuration, okay? Because this is where we relay the data. So I will skip the IP interface because I showed you already on the other system. I will go here to the MTP2 link. You see here, I have two MTP2 links. The reason is that if I bring back my diagram here, I have one MTP2 link for the SG configuration, and I have one MTP2 link for the termination, MTP2 termination. Right? So that's why I have two links here. So here I'm going to look only at the one that is M2UA link, the one going towards signaling gateway, M2UA signaling gateway. So you see here, that's one of the T1s. I could have used other T1s here. This is the time slot. It could have been other time slots as well. The protocol, you see here, there's multiple protocol for MTP2. Usually we will use the latest versions of each of those protocols. And that's it for the MTP2 link. So you see, it's pretty simple here. One thing I need to show you is you need to have in hardware units here, you need to have the MTP2 links license. So if I just go here, And then you have MTP2. Oops, MTP2. You need to make sure you have enough MTP2 links for what you want to create. Okay, so this is in the license section. And then you have to go in M2. Well, okay, sorry, I skipped the SCTP because SCTP is very, you just need to activate it and give it a name. So not much to do here. And then you go to the M2UA section on this side. Make sure you choose the signaling gateway mode in this case. SAP service access point is the same. And here I've used only VoIP 1, but it doesn't, it's normal to do this, okay? And then you have your cluster here. Your cluster here, the interface ID is 100. It's the same as what we configured on the ASP side. This is important. But then when you go here to the M2UA link, here is where it's important. When it's ASP mode, we choose none. When it's signaling gateway mode, we need to select an MTP2 link. That's where we'll get the data flowing through M2UA. So here you have the interface ID 100. That's all you have to configure for M2UA. So once you've done that, then it's done. Your signaling gateway is set up, and you just need to activate your configuration. Okay, you just select this and activate it. Then in the status, if you go here in the MTP2 link and status, you can see if that SG1 is up. Okay. And also in M2UA, whoops, let me just go back. Just show you here. So you have how many time slots, link status, is it up? And then you can also disable this link for testing again. So you can do these things here. And in M2UA, status, M2UA SAP. Okay, so you can see data being sent. You can increase the trace level here to get more information. For clusters here, you can see each of the links. So you can click on each of the links and get more information on the links. Okay, and then if you just go back here in peer, you can see if the remote side is up and active, and then you can force here shut down, but only on the ASP side. If you try to do this on the signaling gateway side, it won't react. Okay, so you can stop this. Okay, so what else did I want to show here? Let me just see. Yeah, okay. So let me continue then with this here. So when you initiate a SG or ASP mode, when you initiate an M2UA connection, it will send some data over the M2UA link. So this is all on this side here is all M2UA. So there will be some init messages. These are sent from the ASP side. And from the signaling gateway side, you will get an acceptance of this initialization, and they will negotiate number of streams, SCTP streams, right? Because here we get the SCTP level, and the window size, the buffer we can keep for those messages. There will be another message here. And on the MTP2 side at this level, it's SIOS. That means the links is out of service, and there's nothing happening on the MTP2 side. Then when the M2UA starts coming up, it sends an ASP up. If it's accepted by the other side, it will say acknowledge. And then for each of those interface IDs, we'll have some messages. So if for each of the M2UA, each of the M2UA interfaces, okay, you will have an interface ID here, notify inactive. Then you will have ASP active being sent from the M2UA side. So here in this message, this is where you will see the traffic mode. So we saw in the configuration, you can choose active standby or load sharing. So in the Wireshark traces, you will see not active standby, but override, okay, or load share. So this is it's This is a source of issues when you don't configure the right mode. And on this side, you will say ASP active if it corresponds to the other side. Once we get this, we'll send the SIO on the MTP2 side. So that means, okay, let's try to put this link in service. Once we have these links set up, then we'll get notified that the interface ID is active. It could be one interface ID or it could be a list. So there's configurations in M2UA that sometimes you get more than one interface ID per message. So you will get for the first interface ID an emergency alignment because that's the first one that you bring up. And you want to bring it up quickly. So you will have an SIE. So that's a emergency bring up of the MTP2 link. Once the link is brought up, it will have the state confirmed for the first interface ID and the established confirm as well. Okay? Once you get this, then here on the MTP2 side, you will get fill-in signaling unit. So these are just messages that are sent to keep the link, the MTP2 link up, but it will be accepted by the other side. Okay? This is for one M2UA link. So for each interface ID, you will need to have another segment like this. The other will not be in emergency. It will be in normal alignment. And it will be on this side, SIN instead of SIE. And we'll be able to show this. I'll show you this in the Wireshark traces we capture. Troubleshooting tools for M2UA. You have the global status from the web portal. You can see if the local IP interface is available. I showed you that already. You can see if the M2UA link is up, if the M2UA peer is up. So you get a global view of what is up in the system. And if it's SJ mode, you only need to look at MTP2 and M2UA. If it's ASP mode, well, you may need to look at the upper layers of M2UA because if MTP3 is not configured correctly, it may want to bring down the M2UA link and try again. So it's not necessarily just the lower layers you have to look in ASP mode. You also have to look at the upper layers. If you don't see anything on the IP side when you need to do an IP connection test, so this is the process to do this. So you connect SSH to the unit. The password for the devices are being sent in the documentation you receive with the equipment. You need then to connect telnet. This is always the same IP for a system. And then you can do this command, ping-b, and then this is what is sent on the line, and you can see if the remote is available. If it goes through a VPN, of course, then there's a chance the VPN is not configured correctly. So you may need to take some traces on these firewalls or these routers to see if the packets are going to the correct destination. You can take a M2UA signaling trace. And actually, when you take the trace, you also take the MTP2 signaling trace. So because the problem could be on the MTP2 side. And usually on MTP2 side, it's pretty simple because it's T1 and time slot. So if you're on the right T1, the right time slot, it's going to work. If you chose the wrong one, then it's not going to come up. But you can still get the trace here when you do this signaling trace, and you get also the M2UA trace. So again, connect SSH to the unit. You just type TB-SIGTRACE. TB-SIGTRACE will look at all the protocols that are configured on the system and will start a trace for each one of them. This will create a M2UA capture file and also maybe an MTP2 capture file if you're in signaling gateway mode. And then you can leave this trace running. You have some tests. You can see packets going through. And then you just need to stop that capture, and you can get those files from the system using SFTP or SCP. Okay. So if that's not enough to troubleshoot the system, you may want to do a TelcoBridges report. So here you have, you want to capture a specific time of date, as time and date, I mean, and then you just do create like this. Here, it will create a report file like this. This report files has all kinds of things. It has application logs. It has a journal of the host, snapshots of the telecom unit, and also a backup of your configuration. Okay, so it has a lot of information on the system, and this is what we ask in our support team to understand what is wrong with the system. Okay, so let me show you this. If I go to the system like this here, right? So I connect SSH to the system. Then here to, maybe I can show you, the interfaces, right? So if I look at the signaling, oh, it's not this one here. I'm on the ASP right now. So the ASP, I look at the IP interfaces here. You see the IP I'm using for SIGTRAN is this IP 160. And if I do just ifconfig or IPA, you can see that it's not here, right? It's 150 and there's other IPs here, but it's not 160 because this IP does not reside on this. You need to go one level deeper. So telnet 172.31.1.1. And then you get on the telecom board, okay? Because all the SIGTRAN and TDM links and MTP2 is handled by the telecom board. And here, if I do ifconfig-a, here I can see that this is where my IP is configured, right? The 160 is here. And one of the thing I want to do is ping the remote side. To allow me to ping the remote side, I need to do ping dash capital B. And 160 is my local IP, and 181, sorry, is my remote IP. Then I can see if it's available, right? So if I try to ping something else, it will say unreachable. All right, so this IP here for my setup is a local IP, but it could be and usually is a public IP that you need to reach here. So it needs to go through multiple routes. So it could be something that doesn't work here. And the remote side needs to accept the the ICMP response to be able to answer this. Okay. The other thing I want to show, and there to exit back to the internal host, I just do exit here. And then I want to do TB sig trace like this. You just type TB signaling trace. And this starts on the system. And you will see that it starts capturing packets right away, detects what we have on the system. And here it's TUCL is TCP UDP and includes also SCTP. And it creates a file name. This file name is important because this is the one you will want to see there. Okay, so I will just do a call so that we see some interesting packets in here, like this. Okay, so I generated a call. Here you see you have some helps and stuff like that. So you can do Q to quit. Yes. Okay, and my file is created. Then what you need to do is go with your SFTP tool, go to the correct folder, and it's not the correct one. So let me bring up the correct one. Okay, so I need to go to this folder, right? Which is very specific, and that's what is in the presentation. And once you're here, you just have to click on TB sig trace. And then you see my IP044 that was just created. So I'm going to just go here and get my IP44 file so that I can look at this. IP44 is here. So of course, we open it up with Wireshark. And this is what we see from the trace. you see packets coming from 181 to 160 and 160 to 181. You can see here SCTP. So SCTP, once it's up, it always sends heartbeats like this, and it pollutes a little bit the Wireshark tray, so you can then eliminate those packets, right, which are SCTP types 4 and 5. So then you're left with only other type of traffic. But here I see I also have SIP on this system. So I want to remove the SIP as well. Okay, so here is what I'm left with once you remove the lower level SCTP packets. If I take the first one here, you see it's a MTP3 management message from 701 to 702. These are the point codes that I'm using for my system, my lab system. So 702, see here, 701. So these are the point codes, and these are MTP3 management messages. So it doesn't go all the way up to WISE up. It stays at MTP3 level. And you see the lower packets are Ethernet. Ethernet, and then you have SCTPs, Stream Control Transmission Protocol. You see the ports that are being used for this. 2904 is the default M2UA configuration. You see here MTP2 user adaptation layer, that's M2UA here. And you have those M2UA packets. In there, you see the interface identifier. I also put it here so you can show it, so understand that this is the interface identifier that is being used. And if you look above that, these are standard MTP3 messages. MTP3 messages. And whether they would be carried over MTP2 or M2UA, it's the same message at this level. Right? And here you see the M3UA point codes that are being used and what type of message is being sent. Here, I want to show you the call I made on the system. So this is an IAM. So you see, if I go in that packet, the lower layers are the same. You have your IP, SCTP, M2UA, your MTP3 level, and you have your ISDN user part. So that's the eyes up. CIC is which time slot is being used for this particular call. And then you have the information about the number that was dialed and the calling party number and stuff like that. Okay, so you have all of this here. And I could filter out and keep only the eyes up messages. And then I see only the upper layers, IAM, address complete message, answer, and release. On SCTP and M2UA, it's possible to send multiple packets. So when you open one packet, you may see multiple things here. And here you see that there's a SACQ, so accept the previous packet, but also another packet, which is RLC. Okay, so you have actually two information inside that same element. Okay. So you have a SAC and a data chunk. So the SAC is for the previous release, and the data is the new RLC, which is release complete. Okay, so you may be able to see this. Okay, so I want to show you also on the other system. So that was the ASP mode. So you see the ASP mode, and I can do the same on the TB sig trace. I can do the same on the other system when you on the one that is signaling gateway. And when I do this, then it's gonna capture both the SS7 and the IP traffic. So this IP traffic is the M2UA traffic. So that will be the same as from the ASP system. Here we get the signaling gateway MTP2 link information. But since I'm connecting locally with a loopback, then I also have the eyes up. So here it's called SS709. So I'm going to do another call just to see that in my system. Like this, then I go back to my SFTP to get the data. Here, TB sig trace. Then I have my SS709 here. So I'm gonna go here, SS709, and I can keep also the IP1 and the SS7. Well, I can show you the IP first, which is this one here. So the IP, you see, it's the same type of messages, MTP3 management messages, and somewhere you will have your eyes up traffic. Here, eyes up traffic, AIM, IAM, sorry, ACM, ANM, and release complete. So these are the same messages. That's the same trace that you will see from the ASP side. It depends where you are. And then you have your MTP2. Okay, so MTP2, the way it's shown is here. You see MTP2 message transfer protocol 2. These are the MTP2 packets. So you see it's not being carried over IP here. It's really configured as MTP2, but the upper layers here, MTP3 and well, eyes up is further down the trace here. Eyes up messages here are shown as well. Okay, so you see the upper parts here are the same as the IP trace and M2UA IP trace. The only particularity, if I just put here, eyes up, the only particularity here is I see two packets with the same message because in my system, well, I captured this link here and I also captured this link here, right? So the data is being received and sent. Okay, so I have it both ways. So that's why I see it 2 times here. And you see it's a different link here. So if I want to keep only the ones from the initial or the signaling gateway, I need to add another prepare as filter and selected. So then I see only the ones from the signaling gateway side. Okay? If I take 2, I see only the one from the right side here. Okay, so that's signaling link 1, signaling link 2. Yeah. Okay, so this is what we get. And the upper layers are the same. It's just the lower layer. You see, MTP2 is very simple. There's only a forward sequence number, backward sequence number. Only you have a few things here. Okay, but this that can help you a lot to troubleshoot if your packets are going normally on the TDM side, normally on the IP side. So you will see all of that. I talked to you about the TB report, which is down here. So you can click on TB report, just create a new snapshot, take the time range here. It's going to create a file that you can use to look at the logs of the system. And I think that's all I wanted to show on this troubleshooting. Yes, correct. So let me just go back here to the presentation. Here are documentation you can have access to. T-Media product installation, M2UA overview, M2UA configuration, troubleshooting, and support. So I took the links here to show you what we have. So this is open documentation. Anybody can have access to this. You see in product installation, you have for different types of products, either TMG or TSG devices, and it shows you how to configure a standalone or a 1+1 system. You have M2UA specific documentation and different use cases and stuff here that can be useful. Then you have the configuration. So if you go here, you click on S7 eyes up, you get different things like MTP2, MTP3 eyes up. But for M2UA, you just need to go down a little bit. And you have the M2UA, MTP2 signaling relay mode, which is what you have to configure here. And you have here the M2UA ASP mode, where you will need to create the MTP2 link, M2UA, and no, actually, you don't need to create the MTP2 link for termination. So just create M2UA here, and then you need to configure the upper layers here, MTP3 and eyes up, which I didn't show in this presentation, but needs to be done as well when you're in ASP mode. Links anti-media troubleshooting, so you can take all kinds of things, Ethernet captures, TB sig trace. I showed you. You have information about here, upper layer applications, and other troubleshooting tools. But if you cannot figure it out, then you will reach to our T-Media support team. How to contact us. We have online trainings. The ones we're doing now will be shown on this link soon. And then you'll have other things here that you can access for our support team. So this is all that I wanted to show today. I hope you enjoyed this training. I will meet you then next time. Thank you very much.